It turns out you really can run Linux on a potato. Who knew? What's up everyone, Chris here, and yes, I'm still on the quest of finding the best alternative to a Raspberry Pi, given the state of Raspberry Pi today. And you've seen in previous videos we've already tried a couple of different devices, and being a 3D printing channel, we're mainly interested in controlling our 3D printer with one of these computers, whether that be through OctoPrint, Repetier Host, or a Klipper install. And a lot of these boards are capable of doing that, but we also need to do that securely. And you saw in some of my previous videos we tried Android TV boxes. Some of those boxes can contain malicious software from the factory that might harm your network, your other computers, or possibly expose your personal data. And we don't want that. So enter Libre Computers. They have several options of small computer boards that we could use for a project like this. And these boards came directly from a comment from one of you all in one of my previous videos, suggesting that we try this because they've been using it successfully. So that's what we're going to do today. Let's start by taking a look at what Libre has to offer. So here's a look at the Libre site. They have several different versions, different processors, different form factors that you can use for a Raspberry Pi alternative or other type of computer project, whatever you might be doing. They have form factors for the more modern Pi, like 3 or 4, as well as 2, and different types of processors. The one we're interested in today, because it's very affordable, is called La Potato. It has an S905X processor. And you can get these boards directly from Amazon here in the US with a couple of different memory options. I did get the 2 gig, but I can even get these the same day for $35. So given the price and the availability of these boards, and they're the same form factor as a Raspberry Pi, we definitely need to give one a try. Also, Libre Computers offers all the images that you can use on these boards, so you don't have to worry so much about there being software in there that might cause harm to you or expose your data. Now, it's not as straightforward as it should be. It's not as straightforward as a Raspberry Pi install. You can get it done, but you have to know exactly how to achieve the results that you're looking for. And that's what I'm going to show you today. So we'll take a look at OctoPrint, and we'll also take a look at the Kaya install. The same kind of thing we've done on previous boards. I just want to show you how to get it all up and working, and you can take it from there. So let's check out La Potato here and just see what we got. So here we go. Here's the basic board. This version is the 2 gig version. You can get 2 gig or 1 gig memory options. Again, it is an S905X SoC processor. It's an ARM chip. It has 4 cores running at 1.512 gigahertz. It has an ARM logic video engine, not that we're going to be using that in our project today, but this one again has 2 gig DDR3 SRAM, 4 USB 2.0 ports. Something to consider, it does have a 100 meg Ethernet link. Some of the other boards are going to be gig, so just keep that in mind if you want to utilize that. And then pretty much the standard stuff. 3.5 TRRS, AV jack, HDMI 2.0. But one thing that is kind of neat about these boards is they do have an IR receiver. So you could use something like a remote control or other devices if you like. And you do have your GPIO header. You will need a breakout for that just to confirm the pins are the same. And there's several jumpers on the board that you can control different things. There is power in here, but it is micro USB. So they haven't upgraded USB-C yet. And just for fun, here's a look at the back. Now, one of the biggest drawbacks to this board, you'll notice I didn't mention anything about Wi-Fi. So you are going to have to add that option if you'd like to use it. If you want to use that Ethernet jack, it'll work just fine as well. In fact, it's easier to configure that way. But you can get Wi-Fi dongles that are relatively inexpensive. For this board, I've been using this one. Again, I got it off Amazon for around $10. I'll leave a link. It does work with Linux like I'm going to show you today. But they also sell a version of this on Amazon that has a Wi-Fi dongle, as well as a pretty cool heatsink that covers most of the top here. And since I'm very interested in these boards, I went ahead and got one of those as well. You can see you have the added heatsink and the Wi-Fi dongle, as well as it's a little bit better coded for the GPIO. Still a Libre computer board, just with a few different options. And you know that you're getting a Wi-Fi dongle that's compatible with Linux. And with all the added options, it's only about $10 more. That's about what one of these Wi-Fi dongles costs, so you might consider this option if that's the way you want to go. And so just to give you a lay of the land of what we're going to be using here, you need your USB micro power adapter. You can do 2 amps. I recommend going with 3 when you're looking for one of these. Your board, of course, whether or not you want to use Wi-Fi, and an SD card of some type. I suggest getting a number 10, something that's a little quicker than the normal card, but a lot of different cards will work. Libre Computer does have specs on the kinds of cards they recommend you use. Just check their site. So you've got your new board, it was very affordable, your power adapter, your SD card, and you're ready to go. And with a Raspberry Pi, you can just use the imaging tool that I've shown many times before, create an image, load it up, you're good to go. Well, it's not quite that easy on one of these boards. It is a little bit different chip, so there's a few things you have to do to get that OS installed. It's not hard, but you do have to follow it very closely to get it to work correctly. That's why I'm making this video today. So now, let's walk through all the steps to get Linux loaded how you would like to have it on this board so you can use OctoPrint or Klipper. So here we go. We're going to start on the Libre Computer site for our Potato board. We're going to go to Downloads. They have a couple of different flavors you can use here of Linux, different kinds of distros. I'm going to use Raspbian because that's the closest thing to a Raspberry Pi. A lot of you that are familiar with Raspberry Pi looking for an alternative are going to be using that. But feel free to use any Linux that you're comfortable with. The scripting we're going to use today can take advantage of a lot of these different OSs. But we're going to go to Raspbian. It's going to have a pretty good set of instructions of what you need to do to get this up and running. But I'm going to walk you through all these steps. So we need to head over to the distro server to grab our file. Remember, these files can be rather large. We only need the light version, meaning it doesn't have a desktop GUI. We're going to run it just as a Linux server. And really all you need to do is find the correct chip for your board. Again, we're running this S905X on the Potato. So up here, these are the more well-rounded versions with the desktop. These are the lighter versions down here. You can kind of notice the size. Again, it is almost 1 gig even for the light version. But we're going to grab this one right here. And when that download is complete, you can still use your Raspberry Pi config tool, or you can use something like Win32 Disk Imager if you wish. Anything that's going to write an image to an SD card should work just fine. But I'm going to show you a few tips to make this easier for you to configure. So let's get it writing and then we'll move on. So we're going to choose OS, we're going to go down to Use Custom, and then find that image file that we just downloaded. This is the one we want right here. We'll hit Open. Then mount up your SD card, the one you want to use for your small board computer. And then down here in Options, we want to change these up just a bit. Now, not all of these options are going to be recognized on this distribution of Linux. They're not going to help you. But what it will do is give you a script that it runs at the first boot of a Raspberry Pi that we can gain some information from. Now, even if you set hostname, it's probably not going to take over for the Potato. But you can go ahead and give it a try if you wish. Again, it will put it in the startup script. So we'll just call this Potato. Enable SSH. That's not going to work the same way with the Potato as well. But I'll show you how to fix that. So we're going to go ahead and enable it and enter our username and password. We'll just go Chris and password just for this video. And the main reason we're doing this is because this imaging tool is actually going to encrypt that password in your startup script. And we need that encrypted password to get up and running. So we'll go ahead and let that complete. You can configure your Wi-Fi information here, but we're still going to have to create another file to get it up and running for this board. But you can go ahead and punch it in just so it's part of that startup script like everything else we're doing here. You can go ahead and set your country LAN code, but we're going to take care of this as well in the supplicant file. And feel free to set your location. And then we can save. And go ahead and hit write. Remember, it's going to wipe out everything on that SD card. So while that image is writing, a bit on why we're doing it this way. Raspberry Pi OS has changed over the years, as you would assume. But now they expect you to punch in your username and password via a console on one of these computers. Meaning you would have to plug in a monitor, a keyboard, maybe even a mouse to get it up and running. It's a little more secure that way, but we have no interest in doing that here. We don't want to have to mess with any peripherals. We just want to be able to get it on the network and start running OctoPrint or our Klipper install. So that's why we're configuring it this way. This is the easiest way that I could find to get it up and running without having to do all those extra steps. So now that our image is complete, we do have to update a few files before we get it over to our computer board, but let's do that now. So our image has been written to our card. I'm going to go ahead and remount that card so that we can alter some files on it. Let's cancel this, hit continue, and we'll open up the boot partition on that card. So let's tackle these issues one at a time. So we're going to need SSH access to set up Klipper or OctoPrint. We have to run those commands. You see me do that in stuff like the putty tool. I do it in a lot of these videos. But it's not enabled by default. So it's easy to get that going. We're just going to right click here on our SD card, hit new, and then text document. I highly recommend you use something like Notepad++ to create these files because they have to be in a Unix format. But for this one, all we need is a file called SSH. It doesn't have to have an extension on it. In fact, make sure that it doesn't have an extension on it. It's going to warn you that it doesn't. If you can't see the extensions for your files, go to View and check this box right here, File Name Extensions. So just having this file on first boot, that will enable SSH. One problem down. Now next, we need to give it a default username and password. And remember, we have to use the encrypted password. So again, I'm going to right click. I'm going to create a new text document. This one, it's going to be called user.conf.txt. And we're going to have to edit that file. So let's open it up in Notepad++. We just need one line, but it has to be very specifically entered. So my username is Chris. And my password is password, but again, you have to use it encrypted. And that's why we entered it in our Raspberry Pi config tool. Because when you do that, it puts it in the startup script encrypted, so we can utilize it here. So go back to your SD card, and we're going to take a look at this first run shell script. We'll just right click and edit in Notepad++. And up here where it's doing the user config pi, here's your username, and here's your encrypted password. Copy everything between those tick marks. We'll just Control-C and copy. We'll go back to our user.conf text file that we're building, and we'll paste it right here. That's password after it's been encrypted. So that'll get our user set up. One thing you have to make sure you do before you save this file is go to Edit and go to End of Line Conversion and make sure it's in Unix format, because it won't read it correctly if you don't. That's why we use Notepad++. Then you can save it. So there's the second problem down. We now have our default username and password we can use. Now, the last thing we need to do, for my install, I want to enable Wi-Fi on the first boot. I don't want to have to use that Ethernet cable. So we're going to right click one more time, New, Text Document, and we're going to create a file called WPA_supplicant, SUPPLICANT, and it's not a text file, it's going to be a .conf file. Again, make sure you can see those file extensions, and we'll just hit enter. And yes, we are sure we want to change that extension. Now let's open it up. And on the Libre Computer site, where it shows you how to install your potato board, they give you the format you need to use. I'm just going to copy and paste it from there. There will be a link to this document in the description. You can copy and paste it as well. But this is all the information you need to enter for your Wi-Fi network. Starting here at the top, you need to enter your country code. Those country codes, you can see them in that Raspberry Pi config tool. For the US, it's just US. Then you need to enter your Wi-Fi network name. Remember, the name and password are case sensitive, but mine is BC Wireless. And then down here in PSK, make sure you keep the syntax with these quotes. Enter your Wi-Fi password. And then go ahead, make sure, again, end of line conversion is Unix, and hit save. And that's it. Our image has now been fixed up so that it will start on boot. You'll have SSH access, your username and password will be valid, and it's going to join the Wi-Fi, all in one shot. So now we can take the SD card out of the computer and load it on our potato board. So here we go. We'll go ahead and load up our SD card we just wrote our image to, and we'll power up. And you do have 3 LEDs on this board. Red means power. It should never blink. That just means you have 5 volts. Green, that gives you a status of your storage. So if it's not on, there's a problem with the SD card or the software on it. And then the blue will start flashing. That gives you an idea that something is processing. Things are happening on the board. You can see it start to flash now as it starts loading that OS. Now, probably the hardest part of this whole install is knowing what the IP address is of your new board when it joins the network. It joined the Wi-Fi, but it uses DHCP, so it's just going to grab an IP out of the pool. You can do this a couple of ways. I usually just go to my router and see what the shortest access time is, and then I know that's the device that I just plugged in. Here's my IP. You could also use something like a network scanner. Angry Network Scanner is a great one. That should help you find the IP of your new board. I know it can be a little tricky. It's not that straightforward. But we might investigate if we can use Raspberry Pi.local, but that's really not going to help you much if you don't have this IP. So do it whichever way you're comfortable with. This is how I would do it. So now I have the IP. We have enabled SSH. I can log in using the PuTTY tool. Now, you can use whatever SSH tool you wish. I just use the PuTTY tool because I've been using it for years and years. Now, if you can't find your IP, you can't get into your router, by default, this configuration I'm showing here, you saw it did show the host as Raspberry Pi. So, if you can't find the IP, go ahead and give it a try. Your router or your network might support this. Try Raspberry Pi, all one word, .local. And if there's no other device on your network, this should get you in SSH. If not, you're going to have to use the IP. So let's go ahead and give it a try. It is looking for a key. We're going to go ahead and hit accept. And let's go ahead and try that username and password we entered when we set it up. Chris, password. And we're in. So hopefully, again, if you can't find the IP, this will get you in so that you can start configuring OctoPrint or Klipper. Something I like to do, because I have multiple devices on my network, I like to confirm that I'm using the board that I think I am. And because this is a new architecture for me, I just want to see what CPU I'm running. So if you do ls CPU, it's going to give you information about the processor on your board. So we at least know we're on a device that's running an ARM processor, A53. Or if you really want to know a lot of information about your board, you can do something like dmesg, D-M-E-S-G. It's going to spit out a ton of information, but to get the model-specific info, you could filter through this if you wanted to, but I usually just grep, just put a pipe, grep. I'll do -I to ignore case, and just enter machine. That's going to pull up everything with the word machine, but we're looking for a machine model. It is a Libre Computer S905X. So we know we're on the right board. So from here, we've already got Linux installed. We're on the network. We just need to start installing either OctoPrint or Klipper, whichever one we want to use. I've shown the process to make this really easy in other videos because we use Paul's script for OctoPrint and Kaya for Klipper because they'll run on pretty much any Linux version. But these are very basic installs, so you need to follow Paul's script completely, or the Kaya install. But I'm just going to run through that really quick. A more in-depth video will be in the description below. So the first thing with any Linux install I recommend you do is just do sudo apt update. This will get all the newest repos. Make sure you're up to date. Then go ahead, bring that command back up, and we'll do sudo apt upgrade. This will update all the new packages. And it takes a little while to run because it's downloading things, but we'll be back when it completes. So all of our upgrades are complete. We can go ahead with our install. The first thing we need to do is install Git. so that we can use it to pull things down from GitHub. So we'll do sudo apt install git, and we'll tell it yes. This should only take a moment. It's a very small package, and it's done. Now we're going to pull in Paul's script from GitHub to start the OctoPrint install. Again, links in the description. I have a video just about this. We've got it pulled down to our machine. Now we just need to start the script. If you do an ls, you can see where we have a new directory, OctoPrint deploy. We're just going to use this command, OctoPrint deploy, OctoPrint deploy.sh to start that shell script. And we'll do 1 to prepare system. And we're running on Raspberry Pi OS, so we're going to do option 2. And we're ready to begin. This install actually does run an update and upgrade for you, so you wouldn't have to do it before, but I recommend you go ahead and do it on any brand new install of Linux, just to make sure you're getting the right packages that you need. But this script's also going to go through and install Python, and that takes a moment. So we'll give it a minute. The script has run for a while. Now it has some questions for us. Do we want to use HA proxy? That's so we can keep track of the names of our instances a little better, so we'll go ahead and hit yes. What streamer would you like to use for your camera? The default is MJPEG in OctoPrint. I've had better luck with Ustreamer, so I'm going to go with option 2. Do we want to set up the admin user? Yes. Whatever name you'd like. This is the user that logs into the Pi. Let's set the password. We'll go ahead and let it run the first run wizards. It's much faster than doing it through the GUI. We'll do the default printer profile, and we don't need any of the extra plugins. We'll just do no. So now OctoPrint is set up. We're ready to start creating our different instances. We only need 1, but you can do as many as you want. This computer shouldn't have any problems running 3 or 4 different 3D printers. It's more than capable. We'll just do 1 to do a new one. Since we're using our Wham WXR today, I'll just call this Wham. We'll just use the defaults. And we want to start detecting our printer so that it knows which printer we're using. So we'll just hit yes to start it. Then we'll plug in our Wham USB. It has detected it. It has a serial number. So we're good there. We want to also go ahead and add a camera. So we'll start that auto detection. And we want to add the camera to HA proxy. Now we can plug in our camera. I'm just using this Logitech C920 just for this video. It's plugged in. It found the camera. We're just going to let it use the next port. It knows what to do with it, how to configure it, so we'll just hit enter. You can change the resolution. These are pretty high end, so I'm going to go 1920, 1080 on this one. Hit enter. And we can just leave the frame rate at 5. I mostly just use it for time-lapse anyway. And we're ready to write the changes. And we're all done. We can do 8 to quit. And then we're ready to start using OctoPrint on our potato board. We can just go to raspberrypi.local/Wham. You can also use your IP. Punch in your username and password. It already knows about our Wham printer. We can go ahead and save and auto-connect. Connect up. Check the control tab. Our camera's there. We'll turn on time-lapse. Save changes. And now we're ready to use OctoPrint on our brand new board. So there we go. We're up and running OctoPrint on our potato board. After you get the Linux installed, that initial part that I showed you today, pretty much all the magic is done in Paul's script, or if you're doing Klipper, something like Kaya. We'll take a look at that in a second. But let's go ahead and run a print, do a quick time lapse to make sure the board is running as we expect it to. So there we go, our print's complete. I have my new desk organizer here. The print looks really good. No issues at all with this board and OctoPrint. You should be able to do multiple 3D printers on this hardware, no problems. But I do want to take a look at the Klipper install really quick. Through the Kaya script, I don't think there's going to be any issues at all, but we need to at least try out the first part for all the Klipper users. So back to SSH, the Kaya script works a lot like Paul's script. Make sure you do have Git installed. We did that earlier in the video before we started Paul's script. But again, we're just going to do a Git clone over on GitHub to pull Kaya down. And then we're going to launch the Kaya script. You can see none of the Klipper items have been installed, but let's just do install real quick. And we'll do one for Klipper. You have to run through all of these to get a complete install, but I just want to make sure the install is going to run successfully. We're going to do Python 3, and for this video I'm just going to do one Klipper instance. The script started successfully. It's pulling down the packages it needs. We can add our user to the group. And Klipper has been set up. Just for fun, let's go ahead and make sure Moonraker is going to work, so we'll do a 2. Install, yes. We're good with Moonraker, and just for fun, let's go ahead and install Mainsail. Once that's complete, we should be able to go ahead and go to our browser. And again, we're just going to go to that Raspberry Pi.local. And here's our Mainsail install. So Klipper on this board looks to be working just fine. So there we go. Another alternative to a Raspberry Pi that you have that's very affordable. It's not quite as straightforward as a Raspberry Pi install, but you can definitely get there with a few added items. Also, a lot of the customization I did in this video, you can just plug in a keyboard and a monitor and go through those steps with the wizard, so you don't have to move all these files around. It's just up to you how you'd like to do that. Remember, it doesn't come with Wi-Fi stock, but you can add Wi-Fi for around 10 bucks. So hopefully you found this video helpful. That will be it for today, and I'll see you really soon on the next one.